Hello, welcome back to Algebra. The title of this lesson is called Factoring Trinomials, General Trinomials, which we also call Quadratic Polynomials. This is part one. There's actually many parts of this lesson because this is an incredibly central, important topic of algebra. Up until now, we've learned how to factor things. We've learned how to pull items out of an expression, pull them outside the parentheses. That's what we call the factored form. Factoring, remember, means just finding things that multiply together to give you the expression that you have that's in your problem, right? Then we learned about special forms, special trinomials, special difference of two squares, special addition or subtraction of two cubes that can be factored kind of without thinking because they're special cases. But now we're going to take the training wheels off. We're going to give you general trinomials, which are just three terms, x squared plus 2x plus 5 or whatever. We're going to give you trinomials. We're going to ask you, what is the factored form of that? And I want to talk a little bit here in the beginning because it's very important that you understand most students actually have problems with this in the beginning. And the reason they have problems is because it's probably one of the first times in math that you'll ever get to where getting the answer isn't very straightforward all the time. So what you'll generally have when you learn math is you'll learn how to do fractions and you'll learn how to solve equations, and we just tell you, hey, if you want to divide two numbers, you do this, and this, and you get the answer. If you want to add fractions, do this, and you get the answer. If you want to solve equations, do this, you'll find the answer. But when we tell you, hey, you're going to learn how to factor a trinomial, we can't tell you, do this, and this to get the answer. And you'll see why as we do it. It takes a little bit of creativity sometimes to go one way and see if it works. And then if it doesn't work, you have to change course and go a different direction and see if it works. And that trips students up a lot because they get frustrated. They start thinking they're not smart, or they can't do it, or they're just not good at math. The truth is, this topic requires you to fail a little bit. And not fail the class, but I mean, it requires you to try different things before you can get to the answer. And that's probably why most people have problems with it, because it's one of the first things you ever learn, that you cannot just get the answer by following a recipe. And just as a preview for you, for those of you going on into trig and calculus and so on, there are many areas of math that down the road that we cannot just find the answer just by straight away just knowing exactly how to do it. We have to try different techniques, different ways to solve problems. And in fact, to really blow your mind, there are many equations in math and science that we don't even know how to solve at all. Like, there are literally equations in quantum mechanics and physics and chemistry that we don't know how to solve. We have no way to solve some equations that we actually write down. But luckily, that's not the case for this. We know how to do these problems, but we do have to take a lot of practice. So let me show you. You're going to have to kind of walk through it with me. Don't skip anything. And if you come out the other side of this, you will definitely know how to factor trinomials very well, because we're going to get you lots and lots of practice. So let's stop talking about it. Let's start doing it. First, we're going to recall something you already know. So I'm going to write on the board, recall, something that we talked about a long time ago, FOIL, FOIL. If you haven't watched my lesson on multiplying binomials and FOIL, you need to stop right now. You need to go back and watch those lessons, because you can't understand the factoring, which is what we're doing here, unless you understand what FOIL is. So to refresh your memory, FOIL is if I want to multiply x plus 1 times, for instance, x plus 2. And FOIL is just an easy way to remember it, but really what you're doing is you're taking these terms here, you're distributing the x to each of those terms, and then when you're done with that, you go to the 1 and you distribute that with each of those terms. And you get a bunch of terms at the end and you simplify it. So if I were going to multiply the x times the x, I would get x squared, adding the exponents, and then x times 2, you would be writing that as 2x. Then you shift your finger and say that 1 times x is just x, and then 1 times 2 is then 2. Right? And then you would say, well, I can add these together. So the answer would be x squared plus 2 plus 1 is 3x plus 2. So you already know from the past how to take two binomials and multiply them and get a trinomial answer. Factoring trinomials is all going to be about going the reverse. In other words, I may ask you to factor this trinomial. In other words, this may not even be on the paper at all. I may just give you this out of the blue, and I might say factor that. So let's write that down and talk about it just for a second. What if the problem is the following? Factor this trinomial, x squared plus 3x plus 2. That's going to be your problem statement. We'll talk a little bit more about how to do it in just a second. Before we get there, I want to call your attention to something really important up here. You already know it, but I'm just going to call your attention to it. Notice to get this guy, we multiplied all these terms. X times x gave us x squared. Then we had the outside terms giving us this. Then we had the inside terms giving us this. Then we had the last terms giving us this. Very important to call your attention to something we're going to use a lot in this lesson. Okay? It's the following thing, very simple. The x squared term, the highest power that you get, is always formed by the multiplication of the first terms. The x times the x always gives me the x squared, right? Also, notice the 2 at the end. The constant term at the end is always formed because of the multiplication of the last terms. The 1 times 2 always gives me this. That's going to be important later on. I'll just tell you to remember it. You'll understand in a second. But that's very important. The first terms give me this. The last terms give me this. The inner and the outer terms are what give you these middle two terms. Those are added together all the time to give you this middle term here. So just remember that. Keep that in the back of your mind. So if you're asked to factor something like this, what does it mean? What are you trying to do? What it means is you want to find some things, some mathematical expressions that will multiply together to give you this, x squared plus 3x plus 2. Right? So the first thing you always do is you say, well, let me go ahead and try to see if I have anything common between these terms. I don't have anything in common because 2 and 3 and 1, there's nothing in common there. X squared x, and there's no x at all here. I can't pull out any x's. So I can't do that. The next thing you do is you say, well, is this a special case? Is it one of these special cases that we've already done? Is it a perfect square trinomial or something like that? You look at it and it doesn't fit any of the cookie cutters or the special cases that we've done in the past. So here's what we're going to do. We already know that this in this case equals this. So we already know the answer, right? But let's pretend we don't for a second and say, how would we factor this guy? How would we factor this? What you do is you know that all of these trinomials are going to be the result of two binomials multiplied together. So what you do is you write parentheses down and you leave them open like this. Basically, any trinomial, meaning 3 terms that are quadratic, meaning you have an x squared and some kind of x squared term, then you have some kind of x term, then you have some kind of term with just a number. They can almost always be factored into the product of 2 binomials like this. Now, sometimes they can't, right? Or sometimes they can't be factored into binomials with perfect numbers, like whole numbers, like we're talking about. But for the case, for this lesson here, every problem I'm going to give you will be able to be factored into 2 binomials like this. So pretend you don't know this at all up here. You don't know what that is. But you know that the first term is x squared. And I just told you that the first term always comes from the multiplication of the first terms in the binomials. So what you do is you say, well, if it's x squared, then the only way that that's going to basically happen is if I have an x here and an x here. So you write those first 2 x's down because I know that when I multiply everything out, they're going to give me the x squared. Okay? Then I turn my attention to that last term, the 2. And I told you again over here, remember that last 2 always comes from the multiplication of the last terms in the 2 binomials. So what you have to do is you have to figure out what times what will give me 2. And you can come up with anything you want. Now for 2, there's only one combination. 1 times 2 gives you 2. But if this last number here was not 2, if the last number were like 100, then you'd have a lot of choices because 1 times 100 gives you 100, but 2 times 50 also gives you 100, and 25 times 4 gives you 100, and I can go on, but lots of things that multiply to give you 100. But in the beginning, I'm starting with easy problems. There's only one way to multiply to give you 2, and it has to be 1 times 2. So because the last terms always multiply to give me that constant term at the end, I'm going to put a 1 and a 2 there because I know that those are the only numbers that work. So I'm getting close to the answer. You can see it's starting to match the answer, but we have one thing to do. We have to figure out what signs are going to go between these terms. And I have a lot of choices. I could put a plus sign here and a plus sign here. I could put a minus sign here and a minus sign here. I could put a plus sign here and a minus sign over here, or I could put a minus sign here and a plus sign here. And this is where it starts to get tricky for students because in the beginning, you might pick the wrong signs. And so you might get the wrong answer, and then you might get confused and get frustrated and so on. I kept telling you from the beginning, it's going to take a little bit of trial and error. Everybody, when they factor, even when you get good at factoring, takes a little bit of trial and error. You're going to get some guesses wrong. All right? But let's go ahead and choose the most obvious signs first and just see. Let's go ahead and choose plus and plus. So we know that it has to be plus plus or it has to be minus minus because this last term is positive 2. We know it comes from the multiplication of these terms. Positive 1 times positive 2 gives you positive 2. So it can be that way, or it could have been negative negative, right? Giving you negative 1 times negative 2, that would have given you also a positive 2. So we're just going to go with our first guess and say it's going to be positive positive. So if that is correct, then we should be able to multiply this out and have it work. And we've already done that, we already know, but just for a little bit of practice, we'll say that the first terms give me x squared, the last terms give me 2x. The inner terms give me 1x, and the last terms give me positive 2. These will add together, giving me 3x, so this does multiply out to give us this. So then I know with certainty, without any guessing anymore, that this is actually the correct answer for the factored form of this. So if you don't know, in the next problem I'll give you, you won't know what it is ahead of time. You'll just have to start with this and give me this as the factored form. And what you do is the same recipe every time. You write the parentheses down, leave them empty. You got to figure out what the first terms are, but they're going to always multiply to this, so you put that down. Then you got to look at the last term and you see what these numbers have to be to multiply together. In this case, there was only one possible way to do it, so I put them in there. Then you have to pick the signs right, and the signs have to work to give you the final answer there. Now let's spend a few minutes figuring out what would happen if I actually chose the wrong sign. Let's say that I did this incorrectly a few times. Doesn't mean you're wrong, doesn't mean you're dumb. It just means that you chose the wrong sign. Let's say that instead of this, I just didn't have any idea. I just put plus and minus there because I don't know, I just tried it, right? Well, what's going to happen? The first terms are going to give you x squared. Then the outside terms, negative 2 times this would give me negative 2x. Then the inner terms would give me positive x, then the last terms would give me negative 2. And you can see right away, this is never going to equal what we started with. The minus 2, first of all, is totally wrong. The inside terms also will not add up to this. So this is not correct, right? Not correct. Let's keep going because I think it's worth here in the beginning doing a little bit of trial and error. What if I accidentally did x, 1, x, and 2, and I chose the other sign, minus and plus, right? What would I get if I did that? Well, the first terms would be x squared. The last terms, or the outer terms, would be positive 2x. The inner terms would be negative 1x, and the last terms would be negative 2. But I have a very similar problem. The negative 2 at the end definitely is not what I started with, so that's wrong right away. And the inner terms do not add up. This would add up to positive 1x, different than what I started with. So that's wrong. There's only one more possible combination. I think it's worth it here in the beginning to do it, so I'm going to do it, but I'm not going to do it for every problem. Let's do x1, x2, and I did that one on the next page here. The only other possible combination is negative and negative. So let's multiply that out. X times x is x squared. Outer terms give me negative 2 here, so the negative 2 times x and negative 2x. Inner terms give me negative 1x, because negative 1 times x, so then negative x here. Last terms, negative 1 times negative 2, give me positive 1 times 2 is 2. Now this one is actually a lot closer. The positive 2 here does match the positive 2 here, but the inner terms is going to add up to negative 3x. Negative 3x is not what I started with, so it's not correct. So these signs here are incorrect. So you can see that this one was incorrect, this was incorrect, and also this one was incorrect. And there was only, I guess I'll show you this kind of like a back of the envelope proof. You can take my word for it. You can look at the mathematical proofs that are out there. There's only going to be one pair of binomials that will be able to be multiplied together as a factored form to give you what you started with. There are lots of other candidates, but they will always fail. There will only be one answer. So the good news is on a test, if they say, hey, factor this, you will know that there's always one answer, always one, and you just have to find it. So what we're going to do is we're going to crank through, I've got 4 more problems, I think, here of slightly increasing complexity. And then what we're going to do is we're going to work through them exactly the way we've done here. And then I've got several more lessons to increase the complexity of the polynomials. Because what happens is when these numbers here in the trinomial get larger, then you have a lot more choices of what to put where, and you have a lot more chances to get the wrong answer. But as I've been telling you over and over, all of us have to fail a little bit to get to the right answer when we're factoring our trinomials. So let's go and factor the following trinomial. What if you had x squared plus 9x plus 14. and I said factor this. Now in this case, it's not like the other problem where you knew the answer. You have no idea what this is going to multiply to be. But you do know that it's a trinomial and it's a quadratic trinomial, meaning you have an x squared term. That's what quadratic means. And all of these, or let me say it another way. If these guys are going to have a factored form, then it is going to look like this. It's going to look like the product of two binomials. All right? And what you're going to do is use what we talked about in the last section. The first term of this trinomial is always going to come from the product of the first terms here. So it's x squared. It's almost always going to be x and x because usually you have x squared here. So x times x gives you x squared. So you've solved like probably 1/3 of the problem right there. Then you look at 14 and you just have to think to yourself, what times what gives you 14? Because remember, the last terms are what multiply together to give you the last term here. Now there's a couple choices in this case. 1 times 14 gives you 14. And also 7 times 2 gives you 14. Now with practice and experience, you'll know what the right path is, or you'll have an educated guess as to what the right path is. But for now, just go with your gut. The very first thing you think about when you think of 14 is probably going to be 7 times 2. So just put 7 and 2 because you know they're going to multiply together to give you 14. So you have the variables in place, you have the numbers in place, and now you have to choose the signs. So you know that this is a positive 14 at the end. So if 7 times 2 is going to give you 14, the only way it can give you positive 14 is if these are both positive, meaning plus signs here, or if they're both negative. That's the thing you need to remember. To get a positive answer for 14, you can either have 7 times 2 as 14, positive numbers, or negative 7 times negative 2. If both are negative, you'll also get a positive 14. So your choices really are two. You can have positive, positive, or you can have negative, negative. So for this one, we're just going to choose positive, positive, and see what happens. And the way you see what happens is you check it. You always should check your work here. So this is going to equal x squared. The outer terms are going to give you 2x. The inner term is going to give me 7x. The last terms are going to give me that positive 14 I'm talking about. And when I add these together, I will get the 9x, which means this is the correct factored form of this trinomial. Now, I'm not going to go through a bunch of different signs here, but let's just in our head talk about what would happen, right? What would happen if I didn't put a positive and a positive? What if I did positive, negative? Well, then the last term would be positive 7 times negative 2. That'd give me negative 14, which is different. So that's why I didn't even try one of those. Or if I flip it around and make this negative and this positive, again, I'll have a mismatch and it'll give me negative 14. So that can't be right. So you have to look at the sign of this one. And we guessed positive 7 times positive 2. Now, what's the other choice? Negative times negative, because that'll give me positive 14. But if I do that, then if I have negative, negative, what will happen is the inner terms will give me negative 7x. The outer terms, because this negative would be here, would give me negative 2x. When I add them together, I'll have a negative 9x, which is different than this. So sometimes I'll go through and show you a bunch of different ways in which you could work out and fail. But in this case, we actually guessed correctly first, so I'm just going to stop the problem here because we know that once we find the correct answer, we're done. There's no other possible ways you can get the answer. So we'll circle that and we move on. I just wanted to kind of verbally talk you through what would happen in different cases. Let's take a look at the next problem, which is actually a little more challenging. What if we have x squared minus 9x plus 8? And I tell you, factor that polynomial or factor that trinomial. Well, you're going to do the same thing you always do. You're going to open up these parentheses straight away like this. You're going to have two binomials there. And the first term is x squared, as it always has been, so it's got to be x times x to give me that x squared, right? Then you're going to go to 8, and you're going to say what times what gives you 8. There's a couple of choices. 2 times 4 gives me 8. Also, 1 times 8 gives me 8. So I'm going to go with my first thought. I'm going to go with 2 times 4 because that's generally what I'm going to think of. Now we're going to work through a lot of problems here. You're going to get a lot of experience as we go through it as to what the best guess is in the beginning so you don't waste your time. But here in the beginning, don't worry so much about that. Just worry about understanding the process. So 2 times 4 is 8. That's great. So I'm going to put a 2 and I'm going to put a 4 right here. And then I'm going to try a couple of different things. I'm going to try, because I know it has to be a positive 8. I'm going to try, I know it has to be either positive, positive, or it can be negative, negative. That will multiply to give me that positive 8. So start with the obvious. Start with positive, positive. If that's the case, then we multiply it through. We find out that x times x is x squared. The outer terms give us 4x. The inner terms give us 2x. The last terms give us 8. These add to 6x, which is not what we have here. So no matter how you really want this to work, because it's just beautiful and you love it, it's not right. So that's incorrect, right? So what else could it be? Let's open up some new, let's do it with a different color. Let's open up another candidate. Let's say, all right, we like 2 times 4. It seemed to work pretty well. So we'll do that again. And we'll put the 2 and we'll put the 4. 2 times 4 is 8. The positive didn't work, so we'll put a negative and a negative there. Let's see if that works. So what we'll have then is the first terms will give us x squared. The last terms, don't forget it's negative 4 times this, will give a negative 4x. Inner terms will be negative 2 times this, giving you negative 2x. Last terms, negative times negative does give me that positive 8. But notice what happened is everything's correct except, again, the middle is wrong because it's negative 6x. That's not what I started with. So this is wrong. So here is where on a test you start to get a little worried. You're like, well, 2 times 4 is 8, but it's not working. Then you start doing crazy things, like you start changing this to positive and this to negative. But you know that can't work because if it's positive 2 times negative 4 to give you negative 8, that's wrong right away. Same thing if you switch the signs the other way, you'll get a negative 8, that's wrong. So when you run into a dead end like that, you have to abandon the idea of 2 times 4 being the correct choice. That's why I say you have to fail a little bit sometimes to back up the truck and go the right direction. So 2 times 4 is not going to work at all. And so what you have to do is choose something that you think might work. There's only one other choice for the number 8. What times what will give you 8? First, let's put our x's in place. Well, it turns out that you can always choose 1 times the number itself. 1 times 8 gives you 8. All right? And then you have to decide on the signs. Okay, you can choose positive, positive, right? That 1 times 8 will give you 8. But in this case, for reasons you'll see in a second, we're going to choose negative times negative because I know that negative 1 times negative 8 will also give me that positive 8. So let's go and let's multiply this out. First terms will give us x squared. Outside terms will give me negative 8x. Inside terms give me negative 1x. Last terms give me positive 8. So the 8's correct, the x squared is correct. Notice what happens here. I have minus 9x plus 8, which exactly matches my problem statement. So this is the correct factored form of the problem, x minus 1, x plus 8. Now just for kicks, let's mentally think about what would happen if it were plus plus. What if I put plus plus here? What if I guess wrong? I would still get the positive 8, but what would happen is the outside terms would give me positive 8x. The inside terms would give me, if this were positive, positive x. That would add to positive 9x, which would be the wrong sign for the middle. Now what I'm going to do, we still have a couple more problems, but I want to give you a little bit of a preview. I don't want you to stress out too much yet, right? But I want to give you a little bit of a preview. Half of the challenge of factoring these trinomials is figuring out what these numbers have to be to multiply to give you this. That's the first part. And the second part of the challenge is figuring out what the signs have to be, once you pick the right numbers, to give you the correct last term and the correct inner term, right? So there's a lot of things in play here. So as you get more practice with this, as you develop intuition, then the challenge will be for you to choose correctly the numbers of your parentheses and also to choose the signs correctly. How can you make a better educated guess? I don't want you to stress out about this, but I'm going to tell you something. You notice that when we choose the wrong numbers, oftentimes what happens is we get the incorrect interior terms, like this added to negative 6x, that was wrong. This adds positive 6x, that was wrong. So part of the challenge is in your mind when you're choosing what numbers here to pick, 2 and 4, to know that they're wrong, because you know that with 2 and 4, now that I've written it down, that there's no way that these inner terms could ever equal 9. And there's no way that these terms could ever equal negative 9 here. It's just impossible to do with 2 and 4, because if you put 2 and 4 here, this will give you 2x, this will give you 4x. There's no way you could add or subtract them from one another to ever give you 9. So the bottom line is, and if you compare that, let me back up for a second. If you compare that to 1 and 8, if in your mind, if you're trying to think, hey, should I go with 2 and 4 or should I go with 1 and 8? Both of them will give me my last term, but I need to choose wisely. I need to choose the pair of numbers that can give me the last number I want, while at the same time giving me the middle number I want. 2 and 4 can never do it, but if I put 1 and 8 here, you already know in your mind that 1 plus 8 is 9. So at least if I choose 1 and 8, it's possible to get to 9 by adding them. All right? So we're going to get a lot more practice with this. Don't stress out if you don't totally get it or understand what I'm saying. But what I'm trying to tell you is when you choose these last numbers to put in place, try to choose wisely. Pick numbers that can multiply properly to give you that last term, but that can also be added or subtracted from one another to give you the middle term, to at least give you a shot. Like 1 plus 8, you know, is 9. So that's the wiser choice. I went down this road to show you this, but this would be the wiser choice off the bat. All right, we've only done a couple of examples. You know, nobody is going to get good at this by doing a couple of examples. So let's crank through a few more. What if we have x squared minus 11x plus 18? Notice the numbers down here are getting bigger and bigger, which means we have more choices. But always going to go to the same thing. We're going to open up a pair of binomials like this. The first is x squared, so we know the first two have to be x and x. Then when we get to here, we have a lot of different choices, right? We have a lot of different choices. Why? Because 1 times 18 can give me 18, right? But also 9 times 2 can give me 18, right? And also 6 times 3 can give me 18. Right? So there's a lot of different choices that can all multiply together that are valid. But you have to choose wisely, right? I know that if I put 9 times 2 or 2 times 9 to give me 18, that I can definitely get that 18, but I also know that these inner terms will give me 2x, these outer terms will give me 9x, and at least it's possible that 2 plus 9 can give me 11. Now the signs are wrong. I need to figure out the signs. But at least with these numbers, I know it's possible, right? So I'm going to start with that. And let's just say I'm inexperienced, and I'm going to put plus plus here because I just think that could be right. And with experience, you'll know that this is actually wrong, but let's just do it. Let's see what happens. Let's say we have x squared coming from these two terms multiplied. Then the outer terms is 9x. Inner terms is 2x. Last terms is 18, just like I predicted. So the outside terms are correct, but unfortunately these don't add to 11. These don't add to negative 11. They add to positive 11. So this is actually wrong, right? This is actually wrong. The correct answer, let's put it in a different guy here. Let's see what happens if we choose something different. X, 2, x, 9. Well, I know I need a positive 18, so it's got to be either positive, positive, which didn't work, or negative, negative, right? And let's see what happens when we do that. So what we'll have is, first two terms are x squared. Well, outer term is negative 9x. Inner term is negative 2x. Last term, positive 18. And you can see right away that these will add to negative 11x. So this is actually correct. This is the final answer, x minus 2, x minus 9. And you know right away not to waste your time doing things like plus and minus, because if this were a plus and this were a minus, I would get negative 18, which is wrong. Or if I flip it around, plus or minus plus, I forget what I said just a second ago, but if I have different signs in the different locations, I'm going to negative 18, which would be wrong straight away. All right? So it does take a little bit of trial and error, but I'm wise to choose 2 and 9 because at least I think it's possible to add them to get this. If, let's just say in an alternate universe, I choose 1 times 18 to give me this. 1 times 18 seems like it could work, right? But the problem is, if I put a 1 here, let me use down here. If I put a 1 here and an 18 here, then I might have a 1x, and then I would have, from multiplying these, an 18x, and there's no way that I can add or subtract 1 and 18 to give me 11. It's just never going to happen. So you have to choose wisely, and that's what I'm trying to show you by examples. So we have one more in this lesson, but we have a lot of these to practice. You're just going to have to kind of work with me here. What if we have r squared plus 12r plus 20? Don't worry so much about if the variable is different than x. It's exactly the same thing. We're going to break this guy up into two binomials. If it's factorable, sometimes they're not factorable at all. We'll get to that later. But if it is factorable, it'll be two binomials, and we'll have the first term being r times r to give me the r squared. Okay? Now, we need to come up with ideas for the 20. What times what can give me 20? And there's lots of choices. 1 times 20 gives me 20. 5 times 4 gives you 20. 10 times 2 gives you 20. I probably missed some other ones too, who knows. But there's a lot of choices to multiply together to give you 20. And you have to choose the right ones that can give you the right third number, while at the same time perhaps being able to be added or subtracted to give you the middle one, right? So let's go with our gut first. 5 times 4 is the first thing I think of, 5 times 4. But before I even bother with the signs, I want you to do the little exercise. if I leave this in place, these multiplied together will give me 5. I know there's an r there, but forget about that for now. Let's put the r just for a second. And then these will multiply together to give you 4r. Now, it is true that I could put pluses and minuses and change the signs of these things, but whatever it is, it's going to be 5r, either plus or minus, and this will be 4r, either plus or minus. So all I can do is alter the signs of these things by putting different signs in place. But even if I add them, I might get 9r, or if I subtract them, 5 minus 4 or 4 minus 5, I might get 1 or minus 1. But there's no way that I can add or subtract them to ever get 12. So even without going through all of the mess of doing all of it as I've been showing you before, you can just tell by writing it down and looking at the interior terms, looking at the exterior terms, that you cannot add or subtract these things to ever give you 12. So it's just not going to work. So abandon it straight away. Okay. So then you go off to another possibility. You say r and r. What else times what else gives me 20? Well, I know that 1 times 20 gives you 20, right? So then we do the same exact exercise. Okay, I'm not going to put the signs yet. I'm just going to try and see what happens. All right, well, this will give me 1 times r. That'll give me r. And then these guys over here will give me 20r. Now, I can choose the different signs, and that will make the signs different, but I'm going to add them, so it'll either become this minus this, or this plus this, or this minus this. You see what I mean? You can only add or subtract them. There's no way by using the numbers 1 and the number 20 that I can ever get to 12 by adding or subtracting 1 and 20 from each other. It's not possible. So don't bother going through all of the 4 different combinations of signs if you know that there's no way you can get there. So let's go to the third possibility, which, as you probably would guess, is the one that's correct, and that would be like this. We'll go r, r. What else have we left out? For 20, we said 10 and 2 can multiply together to give me 20. So before I go any farther, this guy can multiply together to give me 10r, and then this guy can multiply together to give me 2r. And then you look at these and you say, well, can I add or subtract these in any way to give me 12? And you say 10 plus 2 is 12. Ding, 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 bingo. At least it's possible. It may not be the right answer, but at least it has a chance. Right? So then I go through and I say, well, what signs do I need? I need a positive 20, and I need a positive interior term, so I'm just going to go with the standard plus. So if I choose my answer to be this, let's write it to make it clean over here, r plus 10, r plus 2. Is this, well, I know it's the final answer, but let's check it. Is it the final answer? These are going to give me r squared, outside terms are going to give me 2r, inside term is going to give me 10r, last term is going to give me 20. These are going to add to 12r, exactly correct, so this is why this is the correct answer. But you notice you have to go through a little trial and error, because my first thought would be this. And then probably my next thought would actually be this one, but I wanted to show you this to give you the thought process behind it. So if you followed me all the way to this far, then you understand now how to factor a general trinomial in algebra. That's not a special case. It's not a perfect square or nothing like that. It's just a trinomial, right? And what that means, and we're talking about trinomials that are quadratic, meaning they have an x squared, or the highest power is a square in it, right? If they're factorable, they're always going to be a product of 2 binomials. And you go through the same cookie cutter process every time. Choose the first guys to multiply to give you this. Choose the last guys to multiply to give you that. But when you're making that choice on the last number, you have some decisions to make your life easier so you don't go down the wrong way too far. You want to choose numbers at the end, right, that at least have the possibility to also add together to give you the middle term. So what I tried to show you here is the thought process behind it, but all of this stuff that I'm doing on the board, over time you will start doing it in your mind. Over time, you won't waste your time with 5 and 4 because you know there's no way it's going to give you 12 if you add them, for instance. So what I want you to do is work every one of these problems yourself. Make sure that you understand how to do them and you get the correct answer for every one of these. And then follow me on to the next lesson. Over the next 4 lessons, we will do lots of problems in factoring trinomials of increasing complexity. And the goal there is to just continue to drill it in to give you the skills, but also teach you how to not waste your time too much making incorrect or bad guesses in the beginning.